We are going to review in this video and in the following ones some basic notions of probability. Remember that a probability distribution assigns numbers between 0 and 1 to the objects we are considering, and we can therefore represent it as a function. Now, if the objects that we are considering can be described with any value within a certain range, then we will have a continuous probability distribution. And now we are going to be seeing some examples of this. And if we describe them with values or symbols or numbers or names of things, places, categories, among a limited set, then we will have a discrete probability distribution. For example, if the objects that we are considering are professions of people, then we will have a discrete probability distribution and we will be assigning a probability value for each profession, which can be many professions, but it's within a limited set. Or we will also have a discrete probability distribution if the objects that we are considering are city populations, since we will have a limited number of cities and each city will be assigned a number between 0 and 1, which would be representing the proportion of the population of the country that it contains. Or if we have populations of people by age ranges, like between 0 and 10 years old, 10 and 30, and so on. Or different alternatives for a decision, like if I go to run, if I go to the movies, or if I stay at home. There are three alternatives. Or, for example, the number of email messages that I receive every day. Somebody, they can send us like 12, 15, 100 messages each day. They cannot send me any real number. They cannot send me 13.68 messages. They can only send me 13 or 14, or any number within those two. And always remember that a probability distribution can have many interpretations, according to whatever context we are going to be using it into. It can be an estimate of reality, it can be a quantification of our knowledge, of our uncertainty, it can be the results of a census, it can be many things. In this video we are talking about the characteristics of a probability distribution without yet taking into account much of the context within which it comes up. So now, for example, if the objects that we are considering are the heights of people in a population, then we will have a continuous distribution because within some extreme values, for instance between 50 centimeters and 2 meters, any height is actually possible. Yeah? We can have people who measure 165 centimeters, we can have people who measure 168.23 centimeters, and we can even have people who measure 168.4512 centimeters if we could measure with that precision. Another example is if the objects we are considering are the times that elapsed between two consecutive email messages. Then we would also have a continuous distribution, because depending on the precision we may have values or times between 3.5 seconds between messages, a day and 3 minutes, or a minute with 15.2234 seconds. In any of the cases, any probability distribution assigns numbers between 0 and 1 to the object we are considering. In the discrete case, this function is called a probability mass function, or PMF, and in the continuous case, this is called a probability density function, or PDF. And in some way, the convention is that when we are in the continuous case, density it's really like a proportion, or like the amount of probability per time, if we are talking about time between messages, or the amount of probability per height in the case of people. Yeah? And in the discrete case, we are talking about mass. Therefore, a PDF is usually represented by a graph of a continuous function, and a PMF of a discrete distribution, of course, is usually represented by a bar graph, as we are seeing in this video. And of course, we have the condition that all the probabilities of the objects that we are considering in any of the cases have to add up to 1. This condition in the discrete case is usually expressed as a sum, and in the continuous case it is usually expressed as an integral. A little bit more of terminology. The set of objects that we are considering, whether we are in the discrete or continuous case, whether this object set is infinite or not, is usually called a random variable, and the probability distribution that is described by means of the PDF or the PMF is the assignment of probabilities of numbers between 0 and 1 to the values of the random variable. and these values represent the objects that we are considering. For a continuous distribution, we could even ask ourselves what is the probability of having a value less than or equal to a certain number. For instance, we could be asking ourselves what is the probability that the time between messages is less than 1 minute, or we can ask what is the probability of the heights of people of a person is less than 169 centimeters, and so on. This function that assigns a probability to an interval between minus infinity and the maximum value that we want is called the CDF, Cumulative Distribution Function. And it is a function that in the continuous case mostly is going to be very useful, as we will see later in the notebooks. And just a small subtlety in order to finish this video. Note that a probability that the PDF in the continuous case assigns to a value of a random variable must be interpreted always from an infinitesimal perspective. One way of looking at this in the continuous case, of course, it is that it doesn't really make sense to ask what is the probability of a particular value. Such as, for instance, what is the probability that the time between two email messages is exactly 2.32 seconds? Because actually it is impossible to have an infinite precision in the measurement. We could ask what is the probability of having the time between two messages to be between 2.32 seconds and 2.33 seconds. And in reality, this would be the integral of the PDF between 2.32 and 2.33. In fact, if you think about it, asking for the probability of a specific value would be equivalent to reducing this interval until it has length 0, which is equivalent to a point, which would give us a probability of 0 because it is impossible to have this infinite precision measurement. Note, nevertheless, that the PDF does have a specific probability value for the different object values of a random variable. A consequence of this is that the PDF at any point could even have a value greater than 1, and this is okay. This is simply because the PDF is designed so that when it is integrated in an interval, all the infinitesimal values are used and all of them are summed up to the integral. Therefore, although in any point we can have a value greater than 1, the integral of any interval, including that specific value, will always have an integral less or equal to 1.